Okay. So this starts off giving us a recursive formula for an arithmetic sequence where you get any nth term by taking the previous term and adding 2.18. So that's not a very nice common difference, but it's a common difference nonetheless. It models the percentage of women working in the U.S. labor force for each 5-year period starting with 1980. So in 1980, 51.5% of U.S. women were working. Find the first 5 terms of the sequence in which a sub 1, that's your first term, is 51.5. So a sub 2 is just going to be that previous term plus 2.18. So that'll be 53.68. A sub 3 is going to take that previous term and add 2.18 as well, so that'll be 55.86. A sub 4, add 2.1886 plus 0.18 is going to put us over, so it'll be 58.04. How am I doing? I don't even trust my own mental math. Okay. A sub 5 is going to be 60.18 plus 4, 22. So, in the context of this, we're getting every 5 years about 2.18% more women are working. So that's the recursive formula, always based on the previous year or some data point prior. And then here's the general term of an arithmetic sequence formula, and this is for the explicit. So we will be writing our own explicit formulas. We will be using this explicit formula to find a common difference or to find a certain term and so on. So this will be given to you. You don't have to memorize these. They were given to you last year on the reference sheet as well, so you never had to memorize them. But this is the same formula you used last year. So we have the nth term, the first term, n again is whatever number term we have or are looking for, minus 1 times d, the common difference. So in the first exercise, we're finding the 20th term. So n is 20, so a sub 20 equals something plus 20 minus 1 times, I'm leaving a space for the first term and the common difference, but I'm looking for a sub 20 of an arithmetic sequence whose first term is 4 and whose common difference is negative 7. So make sure, because that d is a negative number, make sure you put it in parentheses so you know to multiply by negative 7 and you don't inadvertently subtract 7. So then we're just simplifying this out. 4 plus 19 times negative 7 is 4 plus 19 times 7. Well, 20 times 7 is 140. So one less 7 than that. So 133, negative 133. And so this will be negative 129. So your 20th term is negative 129. I'm trying to think if I want to comment on something, but I don't know if it's going to come up naturally. So there is a limitation to this formula, and that is that it exclusively deals with the first term. And in my opinion, there's a better version of this formula, because what if they gave us this exact same thing, but they didn't tell us the first term, and they told us that the 12th term was whatever, right? Then this formula is a little bit limiting, because if they told us the 12th term, and they told us that, what the 12th term was, so we could plug it in there, and then we know what the n is, 12, and we know what the common difference is, we would have to find the first term on our own. And then we would have to reuse this formula again, now that we know the first term, in order to find the 20th term. So it kind of would force us to have to use the same equation twice, and a little bit of a maze. What I told my Algebra 2 kids last year, and maybe Mrs. Zig, I talked about this, maybe she didn't, why limit it to the first term? Instead, I gave them this formula. I'll talk more about it in a second. So if it's K and not 1, you're not limited to just the convenience of knowing the first term. If they gave us the 12th term, we could plug in the 12th term there, and then we could use 12 there in order to find a sub 20 where n is 20. It doesn't limit you to having to just know the first term. Now, I gave them this as an expansion of this one. This one was on your Algebra 2 formula sheet. So I on tests and quizzes, I didn't give them this. I gave them what they were going to have on the exam. You have this, but just know that this number 1 here and this number 1 here are all tied into the fact that it's the first term. And if you want to expand it and let it be for any term that might be given to you, you can use a sub k and k. Does this make sense? Okay, so let's actually, I'm going to jump to your homework and see if there's an example of something where I can show you how that's used. So bear with me 1 second. Write a formula for a general term. They don't have anything. I know in the Algebra 2 curriculum it kind of actually came up a lot. So maybe if we have time at the end, I'll pull out that stuff and look for an example. Let's move past it for now. I'll come back if I can, if we have time. The next exercise just puts everything into a word problem. Okay, so really, this isn't very practical. I mean, this is just getting you practice with the numbers and the formulas. What's practical is putting this in a real life circumstance. So a lot of what you will see on your tests and quizzes are going to be these application type problems, these word problems. So this one's about teachers in the U.S. earning an average of $30,532 in 1990. This amount has increased by approximately $1,472 each year. So write a formula for the nth term. So we're using this. And we do know our first term, so we can use this version of it. So a sub n equals our first term is $30,532 plus n minus 1 times our common difference of 1,472. So pretty straightforward there. Do you see what we did here where we made n the number of years after 1989? So a sub 1 would be 1 year after 1989, puts us in 1990, so that we can actually use 30,532 as a sub 1. And then in part B, just using that formula, how much will teachers earn on average by 2020? So what is our n value, do you think, Nathan Z? Nope. Lily, you help them out? 31 years. And again, they tell you since 1989. Does that make sense, Nathan? Yes. Okay, so 31 years. So you're just looking for a sub 31. The 31st term. Now, this is silly to do without a calculator. we would get lost in the numbers. This isn't like a mental math sort of thing. Again, on the tests and quizzes, I'll be careful to write problems that you don't need a calculator for. Actually, you know what? Come to think of it, I think there's 2 parts to this test. I think there's a non-calculator portion, and then just 2 or 3 questions that are calculator. So just to have an advance notice on that. But just type this in. So 30,532 plus, essentially that's a 30 times 1472. So I think you guys can see where this formula comes from. Your starting value, and then you're adding the same thing every year. You're adding 1472 essentially 30 times before we'll get to that next year. And we get 74,692 is the average teacher salary by 2020, supposedly, if this trend were to continue. Okie doke. Any questions? This all review? Hopefully. Okay, now we get into the sum. As soon as you see sum, this is a series. The sum of the first 100 terms of the sequence. So we're adding 1 plus 3 plus 5 plus 7. So 1 plus 3 plus 5 plus 7 plus ... Now, those are only the first 4 terms. This wants the first 100. Okay? So what will the 100th term be? If I were to kind of close off this sequence, take a minute, try to figure out what you think the 100th term will be. How about the 99th term and the 100th term? Give me the last 2. Will not stand for I don't know. You can at least, I think, get in the ballpark. I think most of you still also will get it exactly. How about Ellie? 99 and 101. Does anyone think anything different? Connor? 199 and 201. Anybody get anything different than those two? So, Zach, which one do you agree with? The 199 and 201? How about you, Adam? What do you need to know? If you decide with one of these people, or don't you agree with either of them? Are you suspicious of them? Which one's? Say that one more time. Correct. So he doesn't get how the 99th term could be 99. So this one you're siding more with this one? Why doesn't this make sense? Tell me more about that.
Well, I guess 99 to 101.
Yeah, but so does this one. 199 199 and 201 are 2 apart also. You are, but you just said it didn't make sense. Okay, so we thought about it, it makes more sense. Well, I don't think it makes sense. I thought you were on the right track. Someone explain, just generally speaking, why doesn't this make sense? Steven. Hold on, Jalen. I know you got the answer, so just...
No, it's not right.
Okay, hold on. I'll come to you. Steven? Right, so if you're looking for the 99th term, it's not going to be 99 unless you've been increasing by 1. Yes? Like if the first term is 1 and the second term is 2 and the third term is 3. So 99 can't be the 99th term because we clearly know we're not increasing by 1. Does that make sense? Adam? Yeah, but then you stop. I thought that's where you were going, and then you're like, and then you messed with yourself. So that doesn't make sense. Jalen, what are you thinking here?
I have 197 and 199.
Okay, so now we're in a different ballpark. So it messes with you because and this is a common SAT kind of thought process here, where you know it's in maybe this ballpark, but like without doing it out, how do we be certain? Okay, now here's my thought. When I was thinking logically, I'm thinking I start at 1. To get to the second term, I'm adding 2 one time. To get to the third term, I'm adding 2 twice. To get to the fourth term, I'm adding 2 3 times. So to get to the fourth term, I'm adding 2 3 times. So this, and to get to the fifth term, I'm adding 2 4 times, right? So to get to the 100th term, I'm adding 2 how many times? 99. This is always 1 less than that. Yes? I went right to the 100. So I'm adding 2 99 times. So on my calculator, I just started with 1, and I added 2 99 times to figure out that my 100th term is 199, which means my 99th term is 2 units before that. So the plus 197 plus 199 is correct. Now, I thought about it logically. Why, though, think about it logically when you have this? If you want the 100th term, a sub 100 equals the first term, which is 1, plus n minus 1 times the common difference. So we start at 1, and we're 99 times we're going to add the common difference. That's what I logically figured out by kind of just examining some patterns here. So the formula speaks for itself, but this just allowed us to dig into a little bit logically why that formula is doing the same thing. It's adding 2 99 times, which puts us at 199. All right. So we had to figure that out anyway. Now we actually have to add them all together without manually adding them all together, right? Does anybody remember the special pattern that happened last year on arithmetic sequences that we kind of capitalize on to make this happen faster? No. Okay. Here's what happens nicely with arithmetic. If you add the first term and the last term, what do you get? 200. What if you add the second term with the second to last term? 3 and 197. 200 as well. Because these are increasing by 2 and these are decreasing by 2. And so if you kind of pair them first and last, second and second to last, third and third to last, you keep adding 2 and subtracting 2, going down, and so the sum of all those pairs is always going to be 200. Are we good with that? Now you have how many terms here? 100. So how many pairs of terms are there? 50. So we have 50 pairs times the sum of 200, which gives us 1,000? 10,000. 5 times 2 is 10, and then add 3 zeros. 1, 2, 3. Okay? Now there's a formula for this, which I wrote down here, that the Algebra 2 reference sheet does not give you, and I think this is the only one that it didn't give you, because it logically makes sense. You can kind of figure it out if you just kind of remember this little shortcut and how that logically works. So in this formula, capital S means series, or if you want to think of it as sum, you use it anytime you're adding all of these sequence elements together. So we're looking for, in this case, S sub 100, the sum of the first 100 terms. So n is 100. Your first term was 1, and a sub 100, which is the 100th term, we figured out was 199. So the 100th term you get from the explicit sequence formula. And then you use that in the series formula, and obviously it's doing the same thing, 50 times 200. Does this make sense? So capital S of 100 equaling 10,000 tells you that your series total through 100 terms is 10,000. Any questions? Okay. And here we are with a summation notation that manually would not be wise to go through and plug in 1 and plug in 2 and plug in 3 and plug in 4 all the way up to 25. So here's where we realize, okay, since I don't have a calculator, there must be a shortcut. Okay? So if you start to explore the first couple terms, if you plug in 1, you get negative 4. Plus, if you plug in 2, you get 1. Plus, if you plug in 3, you get 15 minus 9, which is 6. Plus dot, dot, dot. Just the first couple of terms should shed light on the fact that this is an arithmetic sequence increasing by what every time? 5. Okay, so common difference is 5. We're looking for the sum of the first how many terms? 25. So S sub 25 equals 25 over 2. A sub 1 is negative 4, plus we need A sub n, aka the 25th term. That's easy, because we can just plug in 25. 5 times 25 is 125. 125 minus 9 is 116. So now we have 12.5 times 112. Now, again, on a test, I'm going to make those numbers better. I wouldn't do 12.5 so that you won't need a calculator. Because I can't give you a calculator because I don't want you just to plug in the summation notation stuff like you learned last year. That's boring. So 112 times 12.5, and you get 1,400. Again, I'll make those numbers better so that it's more practical to just multiply them without a calculator. But you have to recognize that that's an arithmetic sequence. And what I recommend to some people is just look at the first couple terms, figure out just the first 2 or 3 terms, and well, at least 3. You should be able to pick up on the fact that it's arithmetic. How else could you know that that's arithmetic if you didn't do that? And how else would you then know that the common difference is 5? Stephen? What's the arithmetic formula? Just looking at this, what do you mean? Yeah, it's not from an arithmetic formula. It's just a linear. It's a linear pattern, right? That's like mx plus b. Yes? You're right. So linear things are arithmetic. They increase by the same thing every time. And your slope of 5, that's the common difference. That's what you increase by every time. Okay, so if you recognize that and you're good with, okay, linear arithmetic, that's clearly linear, and your slope tells you the common difference, you can go that way. But if you struggle with that and you want it a little bit more concretely in front of you, just find the first couple terms. You should be able to tell that it's arithmetic. Okay? And then when we do geometric, there's also the geometric series, and there's a formula for that. So other than that, if it's not arithmetic or it's not geometric, I'm not going to make you do summation notation for more than 4 or 5 terms. Certainly not going to have you go through 25 of them, because that would be the only question on your test, because that's all you'd have time for. So if it's something crazy like plugging in 1 through 25, it must be arithmetic or geometric, and you must have a shortcut. Okay? And then lastly here, an adult residential community offers a 6-year plan with costs each year given by this sequence. Can you see the linear already? Okay, mx plus b. So our slope is 1800. So this, whatever this is increasing by 1800 per year, and 58,730 is the y-intercept, or the starting value. So your grandmother has $400,000 in assets. Does she have enough to pay the facility over the next 6 years? So essentially what we're doing is we are using this formula. Now, I'm going to assume that this is the cost for this year, right? And then 5 more on top of that. So that would be 6 years total, correct? So what is our end starting value is the question. Zero, correct. N is 0, because the increase of $1,800 isn't going to happen until next year. The starting value is plug in an N of 0, so we haven't increased by $1,800 yet, and it's just 58,730. And then when we plug in 1, that's the next year. So what are we going to go up to then? 5. So year 0, year 1, year 2, year 3, year 4, year 5, that's going to be 6 years. That's where it's like kind of a counting principle in math. It messes with you a little bit, because our instinct is just to find the difference and say, oh no, that's only 5 years. But if year 0 is your first plug-in, and then years 1 through 5, then that is 6 years total. Does this make sense? Yeah, that takes a little bit deeper thought. And then let's use our series formula. Okay, we don't want to do this out manually with these numbers. So our series through, let's think, what's our n going to be here? I think we could probably adjust for both ways. But what should our n be? How many terms are we adding together? 6. S sub 6. So we have 6 divided by 2. Now, this is a little bit tricky because the formula uses a sub 1. That's your first term. Our first term in this is plugging in a 0. So what's that value, the first term? 58,730. Our last term we're going to get by plugging in a 5. So first of all, what's 5 times 18? 90. So, and then add 2 zeros. Well, I didn't line it up right. So I have to add 9,000 to the 58,730, which is going to give me 67,730 as my last term. So that'll be 3 times, I'm going to add this to 58,730. 126,460. So 3 times that. $379,380. That's not good. Okay. That's expensive. Just when you thought Grandma was going to leave something behind you. Right? And she spent it all in a nursing home. Does she have enough? Yes, because she's got $400,000. It's not going to your piggy bank. It's going to long-term care. For the let's do this manually because we have a minute here. The first year is 58,730. I mean, the general population would figure it out manually, probably, right? Because people don't know these formulas and so on. But if you work in this industry, you're not going to figure out all these things manually every time. You're going to use a formula. And so, if you were in this industry, you would use what we're using. But here, 58,730 is what they pay the first year. The next year, they're going to pay 58,730 plus the 1,800. The next year, so year 3 we're about to get into, you're going to pay 58,730 plus 1,800 twice, because it had 2 years to increase, right? So that's year 3. Year 4, you're going to pay the 58,730 plus the 1,800 3 times. That's year 4. Plus, and you can see where this would get confusing, and then your head spins. 58,730 plus 1,800. So you've increased 4 times. That's year 5. And then year 6 would be the 58,730 plus 1,800 increased 5 times. Moment of truth. There's nothing worse than when I teach you one thing and then I find out I got it wrong. So that manually is, how you would handle that. All right? I got a question for you. I want to go back to this one so that we can see how this works. Let's pretend. Gotta make it up. Let's pretend I want you to find the 100th term of an arithmetic sequence who's got an a sub 5 that's 18 and a common difference equal to 2. So I'm not giving you a sub 1. So what I was saying before is we could forget about the fact that we're looking for the 100th term momentarily. We could use the fact that the 5th term is 18, so use an 18 out in front. N is 5, common difference is 2, and that would allow us to find the first term. And then once we knew the first term, we could go on and find the 100th. Or we can just use this, where we're looking for a sub 100. So n is 100. Our common difference is 2. And we were given that our 5th term is 18. So a sub 5 is going to be 18. And k is 5. And this would get us immediately to our answer without having to do 2 separate calculations. So 18 plus 95 times 2 gives you 208. Okay? Now you guys are just trusting me. Did you do it the long way? Oh. The long way you would have to find, let's see, you have The fifth term is 18. A sub 1 you don't know. 5 minus 1 times 2. That's 8. The long way you'd find that a sub 1 is 10. Then you'd go back and you'd use 10 plus 100 minus 1 times the common difference of 2. 10 plus 99 times 2. Also gives you 208. It's just two separate calculations that way. Alrighty. Your homework there?